Visualizing solid shapes for class 8. So I would request to take this chapter with a full enjoyment, as it's slightly geometry, and how important is geometry. Some of you after 12th who would like to take engineering as a subject, you know that machine drawing is one subject which is there in your first year. So I know it's very early for me to tell you all that, but then when you go for engineering, slightly you need to know this is the start of your career. So basically the roots are from here only. So I would always encourage that you should not ignore geometry, and that's main thing in this chapter. And this chapter is also important from one point of view. So if parents are watching this video, I would request that in case there are students nearby, they can just take a A4 sheet paper and just draw the figures. And though you can watch this video a number of times, but then if whosoever is there, if any parents are watching, then in case kids can come, and as I tell you, there are some tricks I'll tell you which are not in your NCERT. So those tricks will make you very much familiar, and you would love to do that again and again, the thing which I tell you here. So let's get started here. This chapter I will tell you faces, edges and vertices, then 3D figures. So basically there are some 3D figures, 3-dimensional figures in this chapter which are important. And once you know faces, edges and vertices of any 3D figure, so any 3D figure is a 3-dimensional figure which has length, breadth and height. So we will take some important 3D figures, and then we will know, once we know the faces, edges and vertices, then there is a Euler's formula. So these are the three things which are the most important in this chapter. Other things are also there which are very simple. You can just refer to your NCERT. Basically the top view, side view and front view of any 3D object. That I think you all can manage. But the questions which will come from this chapter will be either from the Euler's formula, or it could be any object given to you, a 3D object, and you will be told to know to tell the faces, vertices, or maybe just make the diagram and answer the questions. So in this chapter, first you know faces, vertices and edges, and then the most important is to draw the figure. Just keep up A4 size sheet paper and just draw the figure with me, okay? And I'll then give you the tricks. So this is now there are 2 or 3 things which are very important in this chapter. First of all, this is a chart here. So I'm not going in this order. I will tell you some important things in this chapter. Cube, cuboid are 2 figures which are important. So you all know that cube is made up of squares. So there are 2 squares. There are 2 squares here, and then there are 1, 2, 3. So I have drawn these squares separately. So they're all squares and they're all connected to each other. Whenever 2 faces are connected, they are connected by edges. Remember this. 2 faces are connected by edges. So these are 2 faces. They are connected like this. So whatever lines you draw to connect these 2 faces are edges. So whenever you draw any object on a A4 size sheet, whatever attempt you are making to draw those lines to make that figure, like you make a cube, this cube, dice is also cube. So all those lines are edges, right? So edges will be always obviously more than the faces. And what are the vertices? So vertices are the main points. Whenever the 3 plane surfaces join, so in this figure, well, this is one face, this is one face, and this is one face. So this face and this face is joined by this point. So this point is the vertex. So I'll explain you. Vertices also I'll tell you a trick. So when we draw the figure, so just have your A4 size sheet, A4 size paper ready, and just keep on drawing the diagrams. So cube and cuboid are similar, 3D figures. In a cube, there are all squares. So you know how to make a cube. These are all faces as shown in a cube. 1, 2, 3, 4, 5, 6. So 1 and 2, top and down, then sideways. 1 and 2 is sideways, this and this figure. Up and down, 3 and 4, 5 and 6 are 1 at the back, 1 in the front. So this is how you make a cube, right? Same as cuboid, but it is all rectangles. So cuboid is all rectangles, similar kind of figures. So here in what I have explained, each flat part of the solid is a face. Each flat part of the solid is a face, right? Then what is an edge? So I already explained to you all the 2 faces are of solid. The 2 faces are meeting by line or lines. These are edges. So I need to suppose I take these. This is a cuboid now. This is a cuboid. Yeah. So these are all rectangles. So what has happened here? This is one. This is one face and this is second face. So this is 2A is the line joining. 1A is the line joining. So these two faces are joined by edges. So now let me practically, you can draw with me. I am drawing a cube. 1, 2, 3, 4, right? 5, 6, 7, 8, right? 9, 10, 11, 12. What is this? Edges, simple. So there is a diagram here which I will explain you, but don't never cram anything. Just know the concept. This is how you just have to make the figure and everything will be clear to you. This is the cube. Similarly, if it's a cuboid, so your edges are very simple. Faces, there are 6 faces. So 6 faces for cube and 6 faces also for cuboid. Both are 6 faces. And you can see this, right? Same way, you can see the faces I'm making off for a cuboid. One face. This is a cuboid because it's a rectangle. 2 rectangles. 2 faces. Third face. This is third face. This is fourth face. This is the fifth face now. And sixth is one at the back. I'll show you by dots. So you got this 6 phases. 1, 2, up, down, 3, 4 sideways. 1 in the front, 1 at the back. 6 phases. Simple. You know how to make a face and you know how to make a edges. These are all edges again, same way. So I told you about edges and vertices for cube and cuboid. The same concept goes for everything. Same concept. Now we come to different vertices are what? Each corner where 3 faces of a solid meet. Each corner where 3 faces of a solid meet. I already told you vertex. See, vertex is also very simple. It's not difficult. And vertex for a cube, it will be this. Let's draw for a cube. 1, 2, 3, 4. Main where 3, 5, 6, 7, 8. No edges. These points are all vertex. 8. Again for cuboid, same. Keep on drawing, students. This is cuboid. 1, 2, 3, 4, 5, 6. There are no edges. I have not joined them. No edges. There are vertices or vertex. 8. Very simple. Just make the diagram and just follow the concept I am telling you. A trick is a trick. Okay. Now same thing. Now there are 2 more things here which are very important. These figures. There is a table here. So is it important for you to remember the table? Yes, you can cram it if you want to. But no, you should not cram it. See. What are the things here? There are 2 kinds of things here. One is a prism in this chapter and one is a pyramid. Now there are 2 kinds of pyramid here. One is a square pyramid, one is a triangular pyramid, and one is a. So what are the 2 kinds of pyramid here? A rectangular pyramid and a rectangular pyramid. You remember rectangular pyramid? I will explain you. Square pyramid. These are 2 pyramids, and there is a triangular pyramid. 3 pyramids. Square pyramid like a cube. Cube has a square, so square pyramid. Like cuboid has a rectangle. Rectangular pyramid second. What is the third thing? A tetrahedron. Don't worry about tetrahedron by the name. Tetrahedron is simply a triangular pyramid. A triangular pyramid. Now, see, very simple. Follow. Keep your A4 sheets ready. I am making a first diagram is most important. Faces, edges, vertices, everything will be clear. Let's take a triangular pyramid first. What is? You will get a question on tetrahedron. Oh, don't worry about tetrahedron. What is that? Just remember, it is triangular pyramid. So I am making you 3 pyramids for you. One is a tetrahedron. I made it over here. This is a tetrahedron. Can you see this? So now what will happen? ABC triangle. Just make one point O in middle and join the edges. How many edges? 1. AB, BC, AC. Edges AB, BC, AC. Then this is O. This is O in between. Just make one point O and connect all the ABC points with O. O is in the middle. That's a triangular pyramid. Then OA, OB, can you see? OB, and then OC. How many are there? 6. 6 edges, simple. And how many vertices? A, B, C, and one more, O. 4 vertices, A, B, C, O. 4 vertices, right? 4 vertices. And but now the important part here is now we are discussing about square pyramids. So I am discussing the first triangular pyramid. Triangular pyramid has got 4 triangles and 4 faces. See, you can see the triangle ABC, ABO, BOC, AOC, and there is one triangle at the back. I see, I see it shown you a fourth. This is fourth. Fourth is actually I'm showing you at the back. At the back there is another triangle. You can't see that it's a 3D figure. So that's actually the base, right? So there are 4 triangles. Simple. So 1, 2, 3, and 4. ABC is also a triangle. You see ABC is a triangle. So now I will tell you why 4 triangles. ABC, one triangle, AOB another one, BOC another one, and AOC. Clear now? 4 triangles. So simple, you have to remember how to get the faces, figure, and 4 triangles. 4 triangles, 4 faces. Now come to rectangular pyramid. Nothing, no different. First of all, make a rectangle. ABC. You see the rectangle over here? This is a rectangular pyramid. You made a triangle and you made a pyramid. The only difference was that the point O is inside the triangle. This is a triangular pyramid. But in case of square pyramid, there are 2 more pyramids now. Square and rectangle. In both the figures, in square pyramid and in a rectangular pyramid, the point O is outside the figure. Now see. It looks very difficult, it's not. Now I am making a rectangular pyramid. Now can I make it here? Where should I make it? You can see easily. Okay, let me make it here only. Can you see? This I make a rectangle. I'm just explaining you. You can draw. This is a rectangle. Now, what I do? I make a point outside. What I'm doing now? I give this A, B, C, D, and O. I'm giving you a trick how to make a rectangular pyramid. Simply I connect all the points with O. This is OD, this is OC, this is OB, and this is OA. Correct? This is a rectangular pyramid. And how many faces are there then? You see, there is one rectangle and there are how many triangles? 4 triangles. Simple. The 4 triangles are which one? ADO, right? ADO. Then second one is ABO. Then this is BCO. You can say BCO. And which is the 4th one? Can you see? DOC. So 4 triangles, one rectangle. Simple. How many faces? 5. Simple trick. See, diagram is most important. And the trick is one point O outside the rectangle and make the diagram. Faces you know. Edges you know. Very simple. On the line segment, see 1, 2, 3, 4, 5, 6, 7, 8. Whatever lines you're joining to make the figure are the edges. Simple. There are 8. I didn't even see this. There are 8 mentioned here, edges. But see, concept is most important. That's why I am telling the parents to have the students with them and have a paper and pen and just keep on drawing. So whenever you watch this video again, just keep a A4 size sheet and just make the diagram with me. So the diagram is always, see, this is always given in many reference books. But the trick is what I am telling you, right? Now for square pyramid, same thing, nothing. First of all, make a square. See, there is one square and again 4 triangles. So let me make a square over here only. This is a square pyramid. I make a square. This is a square. Point again outside the square. Let me make it a little bit over here. So I connect those points. This is one point I'm connecting. You can write ABCD. A, B, C, D, and O. You connect the points. With B, with C, O with D, and O with A. Same thing. Similar thing, it's a square. Well, rectangle is a rectangle. One square and four triangles. So basically, I'm telling you, when you make the figure, you know the phases now. For square pyramid, one square and four triangles, again five phases. For rectangular pyramid, again one rectangle and four triangles, five phases, right? So edges, you know, 8 for both of them. So these things are clear. So now at least square pyramid is clear to you. Even a triangular pyramid is clear to you. There nothing. One point O is in between the triangle, and there are four triangles being formed, which I told you. A tetrahedron is a triangular pyramid. Now the second part of this is cube and cuboid. You know, there are six phases because there are six squares you're making, all connected, and you know the concept of vertex. Vertices, edges, and with the 3D figure, you know the faces. First, faces are important, and the diagram is important, right? Now we come to prism. See, prism there are two prisms in this chapter: square prism and pentagonal prism. So you make two pentagons. Suppose I go with pentagon first. Two pentagons and five rectangles. See, these are nothing. This is first 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. One pentagon with five faces. Sorry, with five sides. Sorry. Then again another pentagon with five sides. So let me show you again. Pentagon. Again another pentagon. You see the two pentagons, five sides each. Now let's concentrate on the. First we concentrate on the. This is a pentagonal prism I am making. Now we are coming to prism, not pyramids. Prism. First we'll talk about pentagonal prism. We are making a pentagon. Both the sides, five sides. These are two pentagons. You can see. Now what I do? I am connecting the. And now I'll make the edges for you. So edges are nothing. When the two faces are connected, you cannot connect any two faces. These are two faces. If they are not connected, can you make a figure? You cannot make a figure. Simple logic. You cannot make a figure. I have just, because in this cube I was showing it to you the faces, but faces will be connected to make a 3D figure. So those will be through edges, which are simply the lines. Now I just connect and make a pentagonal prism with the edges. So edges, you may remember there are 15 edges, but why should you remember 15 edges? You simply make a diagram. You need to know the diagram first. So now two pentagons I am connecting this. Now see, I connect all the points. If I say this A, B, C, D, E, F, G, H, I, J. Okay, so E with J, right? Then C with H, right? B with no, this is no, nothing much. Now this D with I. Two more things has to connect. I'll make dots here because it's from the back. So this is B with E, B with this is what E, F and G. Okay, this one with B. So you see what is this is what is and this one. So this is a rectangle. This is a rectangle being made. Now what do you see? If you see properly, there are two pentagons, one pentagon, two pentagon, and are there five rectangles? Yes, they are. See. First rectangle, one at the back, the lines which are dotted, that's a rectangle. You see this? That's a rectangle. So if that's a rectangle, then what's the rectangle next, which is in the sides? This is this one rectangle. This is the one rectangle. I'm showing you, right? Then you see these dotted lines which I made a rectangle for you. Then there is another rectangle which is connected. These two rectangles. This is a 1, 2, 1 at the back, 3. You see this? 1 at the back, 3. So this is first, second, third. 3 rectangles you can see easily. Now which is the fourth one? See, I can see that. Did I tell you? C, E, J, H. Can you see that? C, E, J, H. C, E, J, H. The bigger one. Did I tell you that? I told you that. No, I'm sorry. So this is already told to you. The 1 and 2. This is C, E, J, H and D, I, J, E. That's already mentioned. 1, 2, 3. Which is the fourth and the fifth? Can anyone tell? Fourth and the fifth rectangle. I can see. This next, A, D, I, F. A, D, I, F. You can see. I will just mark those rectangles. You see this? Rectangle, another one over there. The figure actually got complicated, don't worry, but now you can see the 4. 1, 2, 3 at the back, which is actually 2 over here. So these are 5 rectangles. Can you see this? I'll explain you here also now. One rectangle, this one. Second one, this one. See again. First one this, or say first one this, second one this. 2. And let me use another marker. So two blue dots are 2 rectangles. This third one is this one. The one which is enclosed by the broken lines. Third one. Right? Which is the fourth one? Fourth one is the bigger one. This is the rectangle, you see? This is the rectangle fourth, and again this is also a rectangle fifth. Now I think it's clear to you. 5 rectangles you can see. 5 rectangles. Right? So 5 rectangles and 2 pentagons. 7 faces. When you connect these 15 edges, very simple. When you want to draw a pentagon, how will you draw a pentagon? Just faces you cannot draw. So there will be 15 edges. See, I'll again let you know how. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Just making the figure, and without edges you can't connect the faces. 2 faces cannot be connected. So there are 15 edges, simple. Have I done any rocket science? I have just drawn the figure. And vertices are like the major points. Vertices are how many? 10. See, very simple. A, B, C, D, E, F, G, H, I, J. 10 vertices. In cube also it was similar. There were 8 vertices. 1, 2, 3, 4. This is a cube. 5, 6, 7, 8. I didn't join by the edges. So this is the concept. You're getting it. Make the figure. Make the right figure. First, check the faces, and then simply check the edges, because then you have to join those faces to make the figure. So while you're making the figure, you just keep on concentrating and writing. The whole figure is made. Check the faces and check the edges and vertices. You know the major points. This is the trick I'm telling you. So this is how. So basically what we did, we know about now different kinds of prism. One prism is left, square prism. That is nothing. These are 2 squares and they are rectangles. So what is the difference between a square prism and a cube? In cube all are squares. In this there are only 2 squares. So the line which are shaded are 2 squares. 1 and 2 are squares. But when you connect these 2 squares, they are rectangles being formed. The rectangles being formed are how many? So this is ABEF is a rectangle. ABEF is a rectangle, and one is at the back, which is CDHG. CDHG is a rectangle. 2 rectangles, and then 2 more rectangles are this is G, this is F. GF, BC, and HE, HEAD. So there are how many rectangles? 4 rectangles and 2 squares. Again 6 faces. So edges you know 12. But you just connect them. Again I can show it to you. Suppose these are 2 squares. One, 2. Oh, it's not very nice. Let me just show it to you here only, in this figure only. You can easily edges. I'm just running over here. This is 1, 2, 3, 4, 5, 6, 7, 8. 8, right? 9, 10, 11, 12. Okay. So basically making my edges, this is 12 edges, and then vertices, you know, again 8. Again 8, is it 8? I didn't even check any diagram over here, 8. Because I can simply see this thing. Not 8, only 10. Why they are 10? First will be 2 squares only. So 1, 2, 3, 4, 5, 6, 7, 8. Is that 8? Is it 8 only? I think I'm correct. This is square prism. Square prism, right? So edges 8, faces this. Okay, there's one more thing, interesting thing here. If you know two things, now comes the Euler formula. Say there are 8 faces only. There are 8 vertices only. 1, 2, 3, 4, 5, 6, 7, 8. Simple. Because there are no edges here. You not connect. When you're not connecting with edges, these are the major points here. So these are the vertices. Now there's one more thing. Why the Euler formula is used? Euler formula, remember, F plus V minus E is equal to 2. This is more or like an equation. So in the right hand side there is 2. Now we know two things. Suppose we know two things, we can always take the third thing. We know faces, let's take this example. Let's take square prism. We know vertices. We know the figure has 6 faces, 4 rectangles and 2 squares in a square prism, right? So this is 6 faces. So we put 6 over here. Vertices are how many? Imagine you don't know the vertices, but you know the edges, because when you're making the figure, you know. How many edges are there? 12. Right? I showed it to you. There are 12 edges. 4, 4, 8, 9, 10, 11, 12. We just put the formula. Faces plus vertices minus edges equal to 2. So question will be like this. How many edges are there in the figure below if faces and vertices given? Now in this case, faces and vertices are given, so you can always take the edge as well. But in this, we'll take this question later on. Let's do this first. So apply Euler's formula. Face plus V, F plus V minus E is equal to 2 to get the vertices. We want to know the vertices. So we know edges 12, faces how much? 6. 6 plus V minus 12 is equal to 2. So 6 plus V minus E is equal to 2. So vertices we want to know. We know the edges. Let's replace it. 6 plus V minus 12. You have to put something over here to make it 2. So this is what? Minus 6. So minus 6. This is coming as minus 6 plus V. This should be, right hand side should be 2 to verify. So what should be the vertex? How many vertices should be there to make it 2? Think. 8. 8 vertices. And that's what I was telling you, 8 vertices. So vertices should be 8. So this question will come to you. These questions will come to you, and two things will be given to you. And you will have to take one thing, which is through the formula. Formula is not the equation. Formula is actually more like an identity. It should always be 2 on the right hand side. So to get 2, we always assume that's 2. So how do we get 2? Now we are solving the left hand side only. 6 plus V minus 12. Simple equation. F plus E minus E. So we always need to get 2 somehow, because that should be 2 always. That's the identity or Euler's formula. So we have known 2 things. Third thing, you can just apply your common sense and put 8 here. When we put 8 here, then it will be 2 here. So what is that 8? So though I have told you how you can calculate, how you can make a diagram and check all the vertices, faces, but still I have this diagram for you. Those who want to memorize it, have all the figures. There is one more prism here, triangular prism. This I didn't tell you. So I have told you square pyramid, rectangular pyramid, and I have told you triangular pyramid. So 3 pyramids I have told you. 3 pyramids I have told you. This is tetrahedron is a triangular pyramid. But there are 3 prisms also. One prism is pentagonal prism. Square prism I have told you. There is one more, which is a triangular prism. Basically it's very simple, simplest. Just 2 triangles and 3 rectangles. 2 triangles, 3 rectangles. This I'm making a triangular prism for you over here only. You can see here only. There are two triangles, ABC, EDF, and you just connect all the points. So I'm connecting all A with D, B with E, and this is C with F. So how many triangles? 2 triangles. So how many vertices? Let's understand vertices first. Vertices A, B, C, E, D, E, F. 6 vertices, right? Faces are the most important. Face, 2 triangles mentioned here, and 3 rectangles. Now see how 3 rectangles. One rectangle you see, BC, EF. Can you see? This is a rectangle in which both the triangles are resting. Both the triangles are resting on this rectangle. On the base of EF, this triangle is resting DEF, and on the base BC, triangle ABC is resting. So the bigger rectangle, which is BCEF, that's one rectangle. Second rectangle is BEAD, and third is ACF. This is D, ACFD. right? So there are 3 rectangles. So 3 rectangles and 2 triangles. Simply know the phases now, 5 phases, right? So vertices edges simple. 1, 2, 3, 4, 5, 6, then 7, 8, 9. Just make the diagram, and then I just make the diagram by connecting the line segments, and that's the edges. I'll show it to you again. Simple. Okay, I'll make it for you over here. I'm telling you the edges. 1, 2, right? 3, 4, 5, 6, 7, 8, 9. Correct? This is a triangular prism. 9 edges. Vertices 6 of all the points of the 2 triangles without the line segment, without the lines joining them. So I think now the concept is clear to you. This is whole chapter all about. This is the most important part. Some question can be verify Euler formula for a square pyramid. Now simple. Just make the square pyramid. For square pyramid, make a square. Make one point outside square. Connect the edges, and then that's a square pyramid. So you will have one square, and you will have 4 triangles. 1 square and 4 triangles. That why we make a figure? Why do we make a figure? To know the phases. So we know the phase 1 square, 4 triangles, 5 phases. Then vertices, sorry, even if you don't know the vertices, edges So edges will be 8 and vertices will be 5. 5 vertices A, B, C, D, O. A, B, C, D, O. O is the point outside the square. 5 vertices, so 5 phases. Edges will be 8. So this is, now if you have to check this, verify the Euler formula. So sometimes the question will have all the things given, and so you will just put the formula F plus V minus E. 5 plus 5 minus 8 is equal to 10 minus 8 is equal to 2. 10 minus 8 is equal to 2, which means it is verified. Which means this thing is correct. It's verified. This figure is correct. So it can, if in case this would have been 6 over here mentioned. In 6 plus 5 is 11. 11 minus 8 is 3. Then it is not. It should be 2. Simple. This is how you verify the Euler's formula, and then this is how you calculate. Suppose we apply Euler formula. F is 5, V is 5, E is what? So they will ask you E. Anything they will ask you. So simply replace the. This is suppose a square prism, right? So for the A part is a square pyramid. So I mentioned left hand side is F plus V minus E. 5 plus 5 minus E. 5 plus 5 is, we have got 5 phases, 5 vertices is 10. 10 minus E is equal to 2. 10 minus E is equal to 2. So 10, if it's 10 here, then what should be E? E should be 8. The edges are 8. So one of the edges are 8, right? Again, the second part is a cuboid. Cuboid, again, 6 phases, 6 vertices, no issues. We will apply the formula, it's given to you. 6 phases, vertices are already given to you, 8, right? 6 plus 8 minus E is equal to 2. 6 plus 14 minus E, 14 minus 12 is equal to 2. So again, 2 things are given, 1 thing you can always calculate. So here we are calculating the edges. Simple, because we know right hand side has 2. That's the identity. That's, or you can say the formula. So this way you can calculate for everything. So this how this was the important part of this chapter. Again for cube, same thing. 6 plus 6 minus 6 plus 8. 8 are the in a cube and a cuboid. This is there are 8 vertices both, right? This is 8. This is 8. So again same thing, similar thing. And last thing is triangular prism. I told you triangular prism. This is what I made for you. 2 triangles and how many rectangles? 3. Phases are 5. Phases are 5. Vertices are 6. I showed you those vertices. A, B, C, D, E, F. Right? So this replace 6. This is 5 plus 6. 11. 11 minus E is equal to 2. 11 minus what is 2? 11 minus 8. No. 9. 11 minus, so edges will be 9 in a triangular prism. Is it a triangular prism? It's a triangular prism, yeah. So this is the whole about this chapter. See, again, I can show it to you. Triangular prism, right? How many? See, this is with Euler's formula we did calculate. We were 2 things are given, 1 thing we can always calculate, or we can make out by the formula. But here we can also see from the diagram. Now you want to know the edges. See. 2 triangles, and you connect the 2 triangles like this over here. So what exactly was done? First 1, 2, 3, 4, 5, 6, then 7, 8, 9. 7, 8. So I hope this chapter was clear. So I told you these tricks, and just make the diagram to know the phases. Diagram should be correct. There were three things in this chapter. They were prism, and the two aspects of the chapter were cuboid. That's one aspect. Second was prism. Prism, there were three prisms. One was the triangular prism. Second was the pentagonal prism, and the square prism. So these were three aspects of the prism. Three more figures, 3D figures, and there were three more 3D figures. Tetrahedron, which is a triangular pyramid. Triangular pyramid. That's a tetrahedron, wherein there is a triangle and a point inside, which is O. So that's one of the pyramid, triangular pyramid. Then there is a square pyramid, and there is a rectangular pyramid. So when you make these figures and you put the figure, suppose you make a square pyramid and you put this as 1 square and 4 triangles. By making the figure, then you know the faces. When you know the faces, you will easily know the edges, because edges, two faces cannot be connected. You just keep the faces like this and you don't connect them. Unless you connect, your 3D figure is not made. So faces and edges, just think faces and edges each time. And vertices, you always know they are the major points without the edges, right? Which I've already explained to you through this chapter. So I hope this chapter is clear to you now. You can now read NCERT and other aspects of this chapter, which you feel which will help you know better things. But then these are the tricks NCERT will not tell you. So these tricks, always remember, have a paper sheet, A4 sheet, make the diagram, know the phases, know the edges first. Faces, edges you know, then you know the Euler's formula in case you're stuck somewhere, to know the third part. And also that will give you enough confidence when you actually make a diagram clearly. So these are the important aspects of this chapter: cuboid, prism, and pyramids. Three prisms and 3 pyramids. So basically 3 and 3, 6, and 2, 8. 8 figures which I mentioned over here are all important, and questions will come from there only. I hope you like this chapter, and if you like it, give a like. Do enjoy. Take care of yourself.